All right, processing daemons. We talked a lot about the different processes and how you kill them, how you start them. So these are just good OPSEC or just notes. Take a good look at the process list. That's a PS command. Disable unnecessary daemons. Nowadays, I have that bullet there. Now it's more like don't enable unnecessary daemons. So if you don't need it, don't start it up. The newer distributions by default have everything that you need to run a basic desktop. Now, there's a lot of fluff that comes into a desktop nowadays because they're trying to make things easier for the user. So there's things like Bluetooth. There's things like, I don't know, the calendar reminders. Yeah, cups, the printer daemon. If you're running a server, you don't need Bluetooth. I mean, that's just one of those things. So you go ahead and turn it off. A lot of these things actually turn on when you log in. There's usually a daemon running in the background just waiting for you to log in. And as soon as you log in, it'll say, hey, this user needs access to this daemon. And it'll create an instance just for you. You can kill that instance on your desktop. But remember, parent-child. So you can kill the child or all the children that spawn from it, but the parent's still there running. So that's going to be the daemon. You need to secure it. I wish these notes would come out a little bit. That's not too bad. So on the notes, I have a command there. Remember when I talked about the run levels, which is when you boot the computer, it'll set up certain services for whatever it is you're going to do. This is one of the commands that you use to stop those services from starting as soon as you boot. That update rc.d. What it does is instead of deleting the scripts, the init scripts, because you might need those in the future, all it does is removes a pointer from the starter folder, basically. And it'll leave all the scripts alone. I put a couple of examples, unnecessary daemons. Telnet, and I'm going to mention this later on in the network part. Don't ever use Telnet. Telnet is extremely insecure. Everything that you do via Telnet is in plain text. So when you log into something, you're going to put your username. It's going to be in plain text. Everybody's going to see it. You're going to put in your password. Everybody's going to see it. So anybody can log in as you. Finger, we don't use that anymore. Not really. SendMail. Unless you're running a mail server, you don't need SendMail. And a lot of the distributions, SendMail comes up because it wants to be able to send mail locally. So you're going to see an instance of SendMail, even if you don't have it as a mail server. So basically, you want to send the email to the root account. There are other ways of doing that. FTP, R logging, anything that starts with an R and is remote is probably not secure anyway, so you can disable all those. Like I said, also Bluetooth, disable that. That's unnecessary. A lot of those services not only are unnecessary, but could be full of holes, like SendMail, in which an attacker can exploit. So get rid of them. Also on the notes, you can use a GUI to prevent some of these services from starting up. And I talked about the syslog, different levels of notifications, whether it's an emergency or something crashed or kernel panic, or just saying, hey, I'm an application and I'm running. It's going to get logged in there. That's what that note means. So, no, I'm jumping back and forth a lot, but a lot of these things, if you don't see them, you won't remember them. So, what am I missing here? Oh, okay. So here, startup applications. Do you guys see how I got there? System, preferences, and then since this VM's kind of small, I had to scroll down. But then startup applications. So this it'll give me this window here, this GUI, and all I have to do is check them off. All right. Now, by me doing this, it's not stopping the service that's currently running right now. It's just saying, hey, next time I log in, don't turn it on. Okay? So just because you did this, right, and you uncheck this, no, I don't want to uncheck the network. But yeah, just because you did that doesn't mean it stopped. It's still running in the background unless you actually go on the command line and stop it. Now next, you log out, you log back in, or you reboot the system, you log back in, they're not gonna run when you log on. Now granted, like I said earlier, there's the parent and children. Some of these things, they're just children, what you're seeing. So you still might see an instance of the service running. So that's why you gotta go into the run levels and stop it.
And if the team gets an image with multiple users, then turning it off for one user doesn't turn it off for all the others.
Correct. So this is an instance that you control, which is based upon your login. So if you want to stop it for everybody, you gotta actually go and kill the parent, pretty much. Oh, another thing that we didn't do earlier was on the administration. Yeah. Click on System, Administration, Users and Groups, and you get this nice pretty GUI. And you can add accounts all day long here. You have to authenticate, obviously. You can create a new account. But you can also do it from the command line. So obviously right now you only see Joe. See, that's one of the instances. You need sudo. So I ran this command here, right? Sudo user add Bob, and nothing happened. If you look over here at the GUI, you see an account Bob now. But the account's disabled because it has no password, it has no other information about it. That's why on the GUI it says null, because it doesn't have that comment. And anybody that's been doing security for a while know Bob and Alice. So now this is a script. Now it's asking me for the password for Alice. Password, full name, Alice, room number, 1, work, 555. Other, is the information correct? So now if I go here, now I have Alice. And since I already created a password for her, she can go ahead and log in. See that you can see that the account is not disabled, unlike Bob, that the account is disabled. So I just created 2 accounts, correct? So I'm going to look at the password file. Go all the way to the bottom. You see Bob? I only created his account. I didn't specify anything else. So by default, it just gave me bin sh for his shell. It says that there's a home directory. It's going to be home Bob. I actually don't think that's created, but I'll check here in a second. User ID incremented by 1. Group ID incremented by 1. Same thing with Alice. 102, 102. Now, I did put comments on Alice, so here you go. All the comments. Home directory and the appropriate shell. Now, they both say that they have a password. I haven't created one for Bob. I did create one for Alice. So, like I said, I created both these accounts here, right? Bob, I didn't give it a password. So, right now, it's a blank password. It's disabled. You have that there. You have that exclamation point.
What did you type to get to that?
Oh, less. Less, and I give it a full path. Slash, space, /etc/shadow. It's a shadow file. And then I'm all the way at the bottom. Now, so you see here Joe and you have Alice, right? I typed in the same password for both of them. They're both the word password. The password is password. These two numbers, that and that, very different. Same word, completely different hash. They're still using the same mechanism, but they're using something called assault, which I mentioned earlier. It's just something extra that they throw into the equation to keep those passwords or the hashes unique. So if you see two of these that are the same, you should pay attention to that, because somebody just copied one from the other. Okay. Not much. Let's couple. Yeah, it's got probably like 2 more slides, man. So, all right, networking. I can't stress it enough. Never use Telnet. Always use SSH. SSH is more practical for sys administration. And I think I got a little note over here in the corner. SSH traffic is encrypted. Telnet is all in the clear. When you use SSH, you can transfer files securely. You can copy them via the SSH tunnel. And you can even mount a remote file system as if it was local, and it still be encrypted. You can use the host allow and host deny files for access control. All it's saying is this IP can log in or can talk to me, or this IP cannot. The one thing about the host allow, host deny is that it's all or nothing. If you don't have anything in there, then you're allowing anything that you want. You're not specifying any IPs that you want to block or explicitly allow. If you put something in one file, then it's going to use both. So if you only put one IP on the host allow, everything else is going to get denied because it's using both files. And vice versa. If you put some IPs in the host deny, everything else is going to be allowed. So all or nothing. Common sense, networking, use a firewall. I mean, everybody that used Windows before knows that you need to have a firewall. There's a lot of bad people out there on the internet that do very bad things. And if they have an opportunity to jump on your system via the network, it's going to happen. I mean, I don't know if you guys ever noticed, if you look at your router at home, it's always blinking. Always, always, always blinking nonstop. It's not because you're doing stuff through it. It's because there's stuff that is being broadcasted throughout the internet, and it's hitting every single IP address you can think of. Just waiting for that low-hanging fruit. So if it's blinking a lot, it might be a good thing. At least you know your internet's working. But yeah, make sure you have a firewall. So in Linux, concept's a little crazy to understand, but IP tables is the firewall in Linux. It's kernel based. So it's a module that's actually loaded in the kernel when you boot up. Net filter, you're gonna see this a lot if you're doing research on the internet. You're gonna see IP tables, you're gonna see net filter. Net filter is just a framework that lets you capture packets, and it'll give programs access to it. So in this case, it's going to be the IP tables. You could put rules to block, network traffic coming in, coming out, coming in between. The IP table is a very, very powerful tool. There's many front ends for it. The one that Ubuntu is using right now, I think it's UFW. Yes, it's UFW, which is command line. They have a GUI version, G, UFW, G, GUI, GNU. Another popular one's Firestarter. So you can, go back home and research those online. But again, having a firewall is important. So local policies, ensure you have the proper permission set, and we talked about this already. You don't want people accessing files that they're not supposed to access. If you have accounts, just stray accounts, they're not being used, disable them. This talks about PAM modules. Use PAM modules to enforce account restrictions. PAM deals with authentication, and it's very powerful. There's a lot of modules that control. You can apply policies. Have a couple examples: password reuse, account lockout, meaning if you put in your password wrong 3 times, it'll be locked out. It'll lock it up for X amount of time. Or the password reuse, you can't use the last 24 passwords you've used before, so just keep, password 1, password 2, password 3, yeah. And the password complexity, that talks about using letters, numbers, lowercase, uppercase, symbols, how many of them, how many they need to repeat, or how many you cannot repeat. Like you can't do 3 uppercase or 3 numbers, and yeah, it's very complex, but it's a very powerful tool. And just a little note on what it stands for there. And paranoid mode. So this is kind of where I live, the paranoid mode. So chrooting, somebody said something about sandboxing earlier. I think it was you, yes. So when you chroot something, it's basically you're changing the apparent root directory for the program. So you might be running the program from /user/sbin/something. When you chroot it, the program thinks that it's running from root. And anything that comes out of there, any children, will be contained to that sandbox, or everything will be under /root. So it's good when you have a server, like a web server, FTP server, DNS, whatever the case is, to contain it to that directory structure. And also the memory addressing, but that's a little bit more complicated. But yeah, it keeps you inside that sandbox. If anything or anybody is able to hack into your system, they're going to be restricted to that structure inside that sandbox, or the directory structure. They're going to think it's root, but once they start poking around, they're going to notice that they're not in root and they can't do much. So they're not going to have access to like your password file, things like that. Linux PSP personal security product. Yes, we have antiviruses, rootkit detections, integrity checkers. So think there's a note. I put a note here. So yeah, most Linux antivirus software is only concerned with scanning mail attachments. So most of the antiviruses that you're going to find on the market, they target only mail servers or proxy servers, things to that effect, because they only want to scan the things that are going to be passing through the system. They're not really too concerned with checking the files that you have on your personal directory, home directory or something like that. But there are some out there that actually do so. Then rootkit detections, or RK Hunter is one of the most popular ones. Basically, it's an application that runs and it'll detect if there's some type of malware that's acting as a rootkit. So it checks various hooks into the kernel and sees if there's applications that are hooking into the kernel that shouldn't be doing it. And integrity checkers, Tripwire, they went commercial, right? Tripwire, I believe so.
Yes.
Yeah, so Tripwire, it was something that was developed by college students. Basically, it does a hash. We talked about hashes earlier, that one-way mathematical function. And it keeps track of those things. It keeps, it'll keep track of when the file was modified, if you change the dates on files, if it's a log and the log is supposed to be continuously growing. So if you delete entries out of a log, if a hacker's trying to cover their tracks, they're going to delete entries on a log file. That's for the forensics class. Yeah, so it'll keep track of those things. So the second it sees that, hey, yesterday the file was this big, and today it's this small, there's something going on, it'll flag it. And you can set it up to, hey, deny access to that file from now on until somebody checks it, that kind of thing. SC Linux and AppArmor, they're kind of similar. So I'm going to run through this real quick. Very complex system, but it enforces mandatory access controls, and it uses the least amount of privileges for the user. And it was developed by the NSA. AppArmor, same thing, but it was developed by a private company, Immunix, and it first came out for SUSE Linux, which is a German distribution. Anyways, SE Linux, it has profiles for applications and users, devices, things like that. And it controls, if it's an application that only deals with the file system and it's not supposed to have network access, it's going to restrict it to just that, just the file system. The second it tries to access the network, it's going to stop it. Same thing with users. You can define different profiles. If a user is going to be an administrator, or users can only have access to certain applications or certain devices, you can restrict it with that. There's some differences between SC Linux and AppArmor, which both of them I think come pre-installed in all the major distros right now. One of the differences is the way they access objects and how you administer them. And I have a little note here in the corner, talks about AppArmor and accessing files and how you can go around it. So use SC Linux, blah, 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 blah. Right. And yes, I think this is the last slide I have. Newbie, right? The security checklist. Basic, use common sense. If it doesn't look right, probably isn't. Keep yourself informed. Things change daily. Again, we've been doing this for many, many years, and I still get on the computer every night and try to see what's coming out today, tomorrow, the day after. Keep your system up to date. Can't stress that enough. There's many ways of doing it via the GUI, just point and click, or you could do it via command line. But keep your system up to date, because they release patches almost daily. Disable unnecessary daemons. We talked about that already a lot. Keep an eye on user accounts. We talked a lot about that too. Disable remote logins, remote desktop. You shouldn't be using remote desktop if you're in Linux, at least not to connect to you. If you want to connect to a Windows box, then by all means, go for it. There are other things that you could use, VNC, you can tunnel through SSH, which is the best thing to do. Use a network firewall, so IP tables or UFW, one of those things. Disable unnecessary features. We talked about that. Disable the daemons. Disable Bluetooth if you're not going to use Bluetooth. Disable all those little things, all the little pop-up things that come up on your desktop. You never know when one of those things is not only going to slow you down, but also it's going to present a whole opportunity for an attacker. Don't settle for the defaults. Talked about this earlier. SendMail is the most popular mail transfer agent in the internet. It's been around for decades. It's also has the most holes of any program out there. Probably second to Bind, I think, which is DNS.
Yeah, right.
Yeah. So if you're gonna set in this case, in this example, a mail server, don't use SendMail. Use something else. So go do the research, read. Hey, this program's better, this is a good alternative, and use that instead. That goes also for Apache, Bind, many others. And then, knowledge is power. You heard that a billion times. Practice makes perfect. Best thing I can tell you, I mentioned this earlier, is go ahead, get on the internet, start reading, play with the virtual machines, try to break them, try to fix them. Try to install something. If it doesn't work, Google it, figure out, why it didn't work. Or if you actually get something working, try to figure out how all the little details about it. And that's how you're gonna learn. Questions, comments?
Decrypting, base 64, go out from hex to ASCII. A lot of it's just using tools that are on the internet already.
Yeah.
That's how we kind of went through the last one. Now we have Scott added, who's supposed to teach us, so I'm assuming that's the route he's going to go. As far as getting too far into depth, I don't think we'll have enough time. 4 hours is a small window.
All right. Same thing with this presentation. I mean, we could talk about Unix all day long, all week long. And still only scratch the surface. I mean, so apologize if you think that this wasn't enough info or very high level. We only had 4 hours, so we got to do what we can, right? But if you got questions, comments, I'm available. Shoot me an email, whatever the case is, and we'll make it happen. A little note at the end: Google is your friend, and so are your mentors. So that's what we're here for. If you got questions, go ahead and ask. I'm more than happy. I like doing stuff like this, not necessarily teaching, but preaching Linux. Yes, I'm good with that. If you got questions, by all means, we'll answer them. So that's pretty much all I got for now.
Questions about
One.